Hello everyone, my name is Dr. Aradhna Sahu, Associate Professor, Computer Science and Engineering Department from Sri Santosh Rungta Group of Institution, Rungta College of Engineering and Technology, Bhilai, Chhattisgarh. Today we are going to implement JPEG compression algorithm using Python programming. Our last video lecture was Understanding JPEG image compression. In this lecture, we have discussed the various steps of techniques used for JPEG compression. Before going to start code, let's take a first look at an overview of the steps that JPEG takes when compressing an image. JPEG or JPEG stands Joint Photographic Expert Group. It is one of the most widely used image compression format. These techniques follows a multi-step process involving several key techniques as seen in figure 1 of the steps of JPEG compression. In this algorithm, first we will perform color transformation and then downsampling. After the downsampling, the algorithm will apply DCT, discrete cosine transform method for coding transformation. It allows a trade-off between storage size and the degree of compression can be adjusted. Then perform quantization. In these steps, JPEG removes some of these high frequency information without affecting the perceived quality of the image. The final step is entropy encoding. It uses RLE and Huffman encoding techniques to compress image files. These two techniques is already discussed in the detail on my previous lecture of the different techniques for image compression. Basically, JPEG is a lossy compression algorithm that results in significantly smaller size with little to no predictable impact on picture's quality and resolution. The output of the JPEG compressed image file can be 10 times smaller than the original one. This format is most common image format used by digital cameras and other photographic image capture devices, and it is also used to storing and transmitting photographic images on the World Wide Web. Now we will start to implement JPEG compression algorithm for images. Our Python program follows following steps for implementing the JPEG algorithm. They are: first, load the image; second, convert the image to the YCBCR color space; third, split the image into 8x8 blocks; fourth, apply DCT to each block; fifth step is quantize the DCT coefficient. Next, encode the quantized coefficients using Huffman coding, and next, create a JPEG file with appropriate headers and segments, and the eighth step is for decompression. Reverse the step, decode Huffman data, dequantize, apply inverse DCT and convert back to the RGB color space. So let's get started with Python code. You need to follow these basic steps. First, we can download and install the Python from official website www.python.org. Make sure to choose the appropriate version according to your operating system. For IDE, Integrated Development Environment, we can choose a code editor or IDE for writing the Python code. Popular options include Visual Studio Code, PyCharm and Jupyter Notebook for Windows, and we can also opt some online Python editors like Google Colab and CodePen. We are implementing these algorithm using Google Colab online Python editors. There are several Python libraries that can be used for JPEG image compression. These libraries allows us to manipulate, compress and work with JPEG file in various ways. Some popular libraries are Pillow, OpenCV, Image.io, PyTurboJPEG and PyLibJPEG. In this video lecture, we will cover all these libraries one by one. Let us go through the code step by step for JPEG algorithm. First, we will understand using PyLibJPEG, then we will cover other libraries one by one. So, this is the complete code for JPEG using PyLibJPEG library as we can see in figure 2. The first requirement of the code is import the required library. So, we write import numpy as np. NumPy is important for numerical operation on arrays. Then write import cv2. It is the OpenCV library used for image processing. Then write from pylibjpeg.utils import get encoders. It is a function from the pylibjpeg library that will use to encode the image. After importing all the libraries, we need to load the original image. So, we use cv2.imRead method. This is a function provided by OpenCV library for reading image files. It allows you to load an image from a file into a variable for further processing. It reads an image name sample file1.jpeg and stored it in the image variable in the BGR blue, green and red color format. The first parameter of cv2imRead method is file name, that is sample file1.jpg. This is the name of the image we want to read. In this case, it is assumed that sample underscore file1.jpeg is located in the current directory contents in the Google Colab. The second parameter of this image is c2.amRead underscore color. This is a flag or an option that specifies how the image should be read. In this case, cv2.imRead underscore color indicates that the image should be read in color mode, which means that it will be load the image in BGR color format. In this format, each pixel in the image is represented as a combination of three color channels: blue, green and red. After executing this line of code, the image variable will contain the loaded image as a numpy array with the BGR color format. Now, going to the third step is convert the image, color image to YCBCR color space. Let's understand the YCRCB color space. Y represents the luminance or brightness color component of the image. It contains information about the intensity of the light in each pixel. CR represents the chrominance component related to the red channel. It contains information about the red color information in each pixel relative to luminance. CB represents the chroma component related to the blue channel. It contains information about the blue color information in each pixel relative to the luminance. The method cv2.cvtcolor is a function provided by the OpenCV library and It stands for convert color. It allows you to change the color representation of an image from one color space to another color space. The first parameter of this function is image. This variable represents the input image that you can convert, which comes from the output of the previous line of code. It is assumed to be in BGR color space, which is the default space for images in OpenCV. The second parameter of this method is cv2.color underscore BGR to YCRCB. It is converting the BGR image to YCRCB color space. By converting the image from BGR to YCRCB, we are separating the images into these three components. These can be useful for various image processing tasks such as color correction, image compression and computer vision applications. After the conversion, you can access and manipulate these individuals Y, CR and CB channels separately if needed for our specific image processing task. The next line of code is for separate these three channels, that is Y, CB and CR channel. For this, we have to write Y underscore channel, comma, CB underscore channel, comma, CR underscore channel equal to cv2 dot split ycbcr underscore image. This line is used to split a ycbcr color image into its three consequent channel. Y means luminance, CB chrominance blue and CR chrominance red. Y channel, CB channel and CT channel. These three variables that will store the individual channels extracted from YCBCR images. After this line of code is executed, you will have three separate images or arrays. Y channel, this will contain the luminance channel of the original image. It represents the gray version of the image capturing its brightness information. CB channel, this will contain the chrominance blue channel. It represents the blue-yellow color information of the image. CR channel, this will contain the chrominance red channel. It represents the red-green information of the image. By splitting the YCBCR image into these three channels, you can process each component individually. Now, we will define the quantization matrix. It is assumed to be a predefined matrix that determines how much quantization should be applied to each DCT coefficients. This matrix apply has higher values for low frequency components and lower values for high frequency components. It especially controls the trade-off between image quality and compression ratio. Then we define a function to apply DCT and quantization to each channel. The function named apply DCT quantization takes a parameter channel Y, CB and CR, applies discrete cosine transformed DCT to it and then quantizes the DCT coefficient using the specified quantization matrix. cv2.dct is the function from the OpenCV library that computes the DCT of an input image channel. The DCT channel contains the DCT coefficients which represents different frequency components of the image. After obtaining the DCT coefficients in the DCT channel, the function proceeds to quantize them. Quantization is the process of reducing the precision of values. In the context of image compression, it helps reduce the amount of data needed to represent the image. DCT channel divide by quantization matrix divides each DCT coefficients by the corresponding value in the quantization matrix. These steps effectively quantizes the DCT coefficient, and np.round method rounds the quantized value to the nearest integer to simplify the data representation. The result is stored in quantized channel, which contains the quantized DCT coefficients. The purpose of these function is to separate an image channel for further compression. The quantization is a lossy operation, meaning that it discarded some information to reduce the size of data. The choice of quantization matrix values has a significant impact on the image quality and compression ratio. Smaller values in the quantization matrix lead to higher compression and lower image quality, while larger value result in better image quality but lower compression. After quantization, you would typically proceed with entropy encoding techniques, that is Huffman, to further compress and store the quantized DCT coefficient as done in JPEG compression. During decompression, you reverse the quantization process and apply the inverse DCT to reconstruct the image. Apply DCT and quantization to each channel. These lines apply the DCT quantization function to the YCBCR channels, resulting in quantized version of each channel. Then the code downsample the chrominance channel CB and CR. So by writing these code downsampled underscore CB equal to CV to resize quantized CB comma quantized CR dot shape of 1 comma quantized underscore CR dot shape of index 0 comma interpolation equal to CV2 dot inter underscore liner, and same code for CR. Here the CB and CR channel are downsampled to match their dimension as required by JPEG format. CV2.resize is a function from the OpenCV library used for resizing images. The quantized underscore CB is the chrominance blue channel of the image that has been quantized earlier in the code. It specifies the target size for CB channel. In this line, it's set to the dimension, width and height of the quantized CR channel. This ensures that both CB and CR channels have the same dimension after the downsampling. Interpolation method to use during resize. CV2 underscore linear is a method that uses linear interpolation to estimate pixel value in the resized image. It is a common choice for downsampling because it provides a smooth transition of pixels. Next two lines is essentially as same the previous one, but applied to the CR channel instead of CB channel. Overall, these two lines of the code ensures that chrominance channel CB-CR have the same dimension after downsampling. This is the important because in this most image compression schemes, the chrominance channels are subsampled to reduce the data size while keeping the chrominance Y channel intact. Matching dimension for CB and CR are crucial for maintaining the color information during decomposition. Then encode the quantized and downsampled channel using pylib library method. the encoded image equal to get encoder. The parameters are quantized underscore y, comma, downsampled underscore cb, comma, downsampled underscore cr. This line is responsible for encoding the quantized and downsampled image data into a compression format. The purpose of this line of the code is to take quantized and downsampled image data, which is in a format suitable for compression, and pass it to the getEncoder function, which presumably contains the logic to encode these data into the compressed format. The specific detail of how the data is encoded and compressed would be handled by get_encoder function. In a JPEG like compression process, encoding typically involves several steps, including entropy encoding, Huffman or arithmetic encoding, and generating a compressed bit stream. The result is a compressed image file that can be stored or transmitted more efficiently than original image data, while introducing some loss of quality due to quantization. Now save the encoded image to a file with open compress underscore file1 wb as f.write method. Finally, the encoded image data is saved to a file named compressed underscore file1.jpeg. In the summary, this code takes an input image, covers it to the YCBCR color space, applied DCT and quantization to each channel, then downsamples the chrominance channel and then encodes the quantized data using JPEG format. The resulting compression image is saved to the file. Implementing a complete JPEG compression and decompression system involves in-depth knowledge of signal processing, coding theory, and file formats. Many open source libraries such as Pillow, OpenCV, Image.io, and PyTurboJPEG, they provide JPEG compression and decompression capabilities directly. You can use this library for practical applications. It provides the direct way to perform JPEG compression. Let us implement one by one and check their results. First, we will start from the Pillow. PIL stands Python Image Library. It is a popular open source library in Python for working with images. The complete code for Python using PIL is shown in figure 3. The first line of code is from PIL import image. This line imports the image class from Pillow library, which is used for working with images. The next line is for define the path of original image. The third line of code is for image file name, that is sample underscore file1.jpg is loaded using im.open method. The image path variable specifies the path to the image you want to compress. The image.open function is used to open and load the image into memory, and the result image object is stored in the variable image. The next line is set the path for compressed file. Then we can use our compressed file using image.save method with the quality equal to 30. We can adjust the quality level from 0 to 100. The higher value means better quality. The term quality setting refers to user defined parameter that determines the level of compression applied to the image. The setting allows you to balance between image quality and the file size when saving or encoded an image in the JPEG format. The result of this code is shown in figure 4, which is developed in Google Colab online editor. In the figure, we can see that the size of original image name sample underscore file1.jpg is 4.52 MB and the image view is in pan of right size. After running the code, we will get the compressed file and we can see it in the left pane on figure 5. Its size is reduced and we can also see the result on right side of the picture. The second library is image.io. This code is very simple as you can see in figure 6. The code explanation is a start from importing the image.io library files. This line imports the image.io library, which is a Python library for reading and writing a wide range of images and video formats. The second line is defining the path. This line defines two variables, image path and output path, where we can store the file paths for input image and the output image. We should take sure that the input image file exists in the specific path during reading the input image. Here, image.io.imRead function is used to read the input image specified by image path variable and load into a variable called image. This variable now contains the image data in a suitable format for further processing. Saving the compressed image with custom settings image.io.imRead. This function is used to save an image to save a file with following parameters. They are first output path. The first argument specifies the path where the compressed image should be saved. The second is image. The second argument is image data to save which was previously read from the input image file. The next is format equal to JPEG. This specifies the output image format as JPEG and the quality equal to 90. The quality parameter determines the compression quality. In this case, the quality of 90 is specified, which is relatively high and result is a smaller loss of image. Quality.codec equal to JPEG ls. This parameter specifies the codec to be used for JPEG encoding. In this case, JPEG ls is chosen for a custom JPEG encoder. JPEG ls is a lossless or a near lossless compression algorithm. And at last, printing a confirmation message after saving the compressed image. This line prints a message confirmation that the image has been saved with a custom JPEG encoder and specifies the output file's name. By using the image.io library with the JPEG ls decoder and a quality level 90, you can save the image in a compressed file that is likely to have a smaller file size compared to uncompressed image while preserving the image's original quality. The exact use of image.io may depend on the specific version of the library you are using. So make sure to refer to the documentation or function signature for any additional detail or option available in your particular versions. This is a screenshot of the code before compression is shown in figure 7. There we can see that the size of image is 216.5K and its picture is displayed in right pane. The picture number 8 shows the result of after compression. Here we observed that the difference between the file size of original and compressed image. The size of reduced after applying the compression. Now we are going to understand the third library files, that is CV2. CV2 refers to the open source computer vision library module in a Python. OpenCV is a popular open source library for a computer vision and image processing task. The figure 9 shows the complete code using CV2 library. The code will start from import the OpenCV library, then read the image. This line reads an image file named sample underscore file2.jpg and stores it as a numpy array called image. These array represent the image with its pixel data. Save the image with JPEG compression using cv.imread method. This line saves the image to a new file named compressed.jpg. With JPG expression applied, cv2.imread underscore jpeg underscore quality, 40. The parameter specifies that the compression quality. In this case, a quality level of 40 is used, which will result in a highly compressed image with lower image quality but a smaller file size. The JPEG compression works by discarding some of the image data. To reduce the file size, lower quality result in more data loss and a smaller size but a lower quality image, while higher quality values preserve more details but result in larger file sizes. The quality value typically range from 0 worst quality smaller file size to 100 best quality larger size. In this case, the quality of 40 is chosen for the higher compression and smaller file size. So, the code reads an image, applies JPEG compression with a quality of 40 that saves the compressed image as compressed.jpg in the same directory where the script is executed. The figure number 10 in a screen shot is a screenshot of the code before compression. Here we can see the size of image is 216.5K and its picture is displayed in right pane. The figure number 11 shows the result after compression. Here we can note that the difference of the file size of original and the compressed image. The size is reduced after apply the compression. And last one is PyTurbo JPEG library. This is a Python wrapper from the Turbo JPEG library which produce fast JPEG compression and decompression. It is known for its spread and efficiency in handling JPEG images. The figure number 12 shows the complete code of the compression techniques. The code we have provided demonstrates how to use the PyTurbo JPG library to read and then compress an image in JPEG format with a specified compression quality. Here is a step-by-step explanation of the code. The first line of the code is pip install PyTurbo JPG. It installs the PyTurbo JPG library using pip. This library provides Python building for the Turbo JPG library, which is known for its speed and efficiency in handling JPEG images. Importing the necessary modules. You import Turbo JPEG modules from the PyTurbo JPEG library, which is the core module responsible for handling JPEG images. The next is for creating a Turbo JPEG instance. The code create a instance for calling Turbo JPEG method. This instance is used to perform the various JPEG related operations. Then read an image file. The code opens an image file named sample underscore file1.jpg in the binary mode, read mode, RB, using a content manager. With it leads the binary content of the image file and decodes it using the jpeg.decode method provided by Turbo JPEG instance. These steps effectively leads the image into memory, compressing and saving the image. After reading and decoding the image, the code proceeds to press it. The jpeg.encode method is used to encode the image data back to JPEG format with a specified compression quality. The compressed image data is written to a new file, that is a compressed.jpg file in binary write mode WB. This file will remain the compressed JPEG under the quality parameter 50. In summary, these code demonstrate how to use PyTurbo JPEG to read, compress and save image in JPEG format. It is particularly used for situations where you need to handle JPEG compression efficiently and required fine-grained control over compression parameters. The screenshot of the code before compression. Here we can see the size of image in 42.5 MB and its picture is displayed in right pane of the figure as shown in figure number 13. The figure number 14 shows the result of after compression. Here we can note the difference between file size of original and compressed image. The size is reduced after applying compression. I would like to summarize the coding steps of JPEG compression. These processes include color space conversion, DCT quantization and zigzag encoding. You would need to implement the functions like RGB to YCBCR, DCT blocks, quantized and zigzag underscore encode to fully implement the JPEG algorithm. Implementing a complete JPEG encoder or decoder is a non-trivial task and requires a deep understanding of image compression algorithms, the JPEG stands and bit manipulations in Python. We would typically use libraries like Pillow, OpenCV, Image.io for practical JPEG encoding and decoding in Python. Understanding the basics of JPEG compression is essential for everyone. Those who are working with the digital images, from photographers to web developers, as it influences how we store, transmit and display visual information in the digital age. Thank you. Looking forward to seeing you in the next video or whenever you need to support. Have a great day. Goodbye.